Okay, so for number 1, we have g of x equals the cube root of x plus 3. I've already listed the reference points. Now, the ones in yellow, those are the ones that we'd like you to use. But I added the one on the top, one on the bottom, because those are like your safety guards. They're the ones that make sure that you graph the right function, that you not graph the x cubed instead of the cubed root. Okay, so it's 2 extra points, but I think it's better that you use them right now. So the k value is 3. That means that we're going to be adding 3 to all the y's. The x's do not change, so you end up with negative 8, 3 minus 2 is 1. Negative 1, 3 minus 1 is 2. 0, 0 plus 3 is 3. 1, 3 plus 1 is 4. And 8, 2 plus 3 is 5. Okay, so now the next thing is to plot the points, so negative 8, 1. And notice I enclosed the reference points, the 3 points that we want you to get used to using, because those are the ones that you should always have. But then the ones on the outside are just there to make sure you graph the right function and not get it confused with x cubed. So negative 1, 2, 0, 3, 1, 4, and 8, 5. Okay, so connect and connect. They also want you to give the domain and the range, and the domain and the range are all reals. You could write like that, or in interval notation. Okay, so number 2, again, I included the 5 points, although the ones in yellow are the ones that we'd like you to get used to using, and the outside ones are just there to ensure that you graph a cubed root and not a cube function. Okay, so again, in this problem the k is negative 5, so the only thing being changed is the y. So the x stays the same. Negative 5 minus 2 is negative 7. Negative 5 minus 1 is negative 6. 0 minus 5 is negative 5. 1 minus 5 is negative 4. And 2 minus 5 is negative 3. Okay, so plot the points, negative 8, negative 7. Negative 1, negative 6. 0, negative 5. 1, negative 4. And 8, negative 3. So I usually start from the inflection point. Remember, that's the point that came from 0, 0, so it's this one right here. So I usually start my curve from there. You don't have to, but again, it's just a habit of mine to start from the inflection point and then curve it out like that. And domain and range is all reals. Alright, in number 3 through 8, you just have to describe how g of x compares to f of x being the parent function, cube root of x, like I have written here in blue. So if you look at number 3, the only parameter affecting cube root of x is k, and in this case k is 6. So you say compare to f of x equals cube root of x, g of x is translated 6 units up, and that's it. Okay, in number 4, g of x equals cube root of x minus 5. In this case, h is 5. Okay, so this means that the graph moved to the right 5 units. So you're going to say compare to f of x, g of x is translated 5 units to the right. And that's the only transformation here. Okay, for number 5, I've labeled the 1/3 is your a value, and the negative in front of the x is actually b, right? So the b is negative 1, so that means that the graph is reflected. So you would write, compared to f of x, g of x has a vertical, so I'm talking about the a first, vertical compression by a factor of 1/3 and reflected over the y-axis, because since the b is negative, it's a reflection over the y-axis, that negative in front of the x but inside of the radical. Okay, for number 6, the 5 in front of the x, coefficient of x, that's your b value. So compared to f of x, g of x has a horizontal, so remember with b, it's counterintuitive, so it's the reciprocal of b, so it's not really 5, but 1/5, so that means that it's a horizontal compression by a factor of 1/5. Okay, on number 7, the a is -2, so the negative tells you there's going to be a reflection, but this time it's going to be over the x-axis. So when a is negative, it's a reflection over the x-axis. The 2 means that there's going to be a vertical stretch, and the 3 is the k value, so there's going to be a move up, a translation. So compared to f of x, g of x reflects over x-axis, has a vertical stretch by a factor of 2 and translates up 3 units. And that's all. Okay, number 8 has an h value of -4 and a k value of -3. So what this means is that compared to f of x, g of x is translated 4 units left and 3 units down. Okay, so for number 9, the h value is -4 and the a value is 3. So remember, a affects the y and h affects the x. So I've already put above each one how they're going to change. So above the x coordinates, I put -4, and above the y coordinates, I put -3. Okay, so I'm going to go ahead and change the transform the points. So I get -12, because -8 minus 4, and then 3 times -2 is -6. -5 for x, and then -3 times -1 is -3. 0 minus 4 is -4, and 0 times 3 is 0. 1 minus 4 is -3. 1 times 3 is 3. 8 minus 4 is 4, and 2 times 3 is 6. Okay, so now we're going to go ahead and plot this. Okay, so now I could go ahead and plot the points. Notice that I gave myself more room on the left side because my x value goes all the way to -12. Okay, and then +4 is my largest x value. So -12 minus 6. So that point would go right here. -5 minus 3, or -3. -4 is 0. -3 3. And 4 6. So 4 6 right there. Okay. So remember, this one has a vertical stretch. So always, like, it might be easier for you to start with the inflection point. So this one right here. So from here we're going to curve it up and out, and then this one we're going to curve down and left. Okay, so for number 10, a is 2, k is 3. So a is going to affect the y. It's a vertical stretch, and k is going to affect the, it affects the y also. Sorry, I made a mistake on that. So let me just erase this here and put the times 2 plus 3. So it might be easier if I just put it like I do in class. Let me just go ahead and change this to 2y plus 3. Okay? Because a is 2 and k is 3. So in this problem, the x's are not going to change. So negative 8. 2 times negative 2 is negative 4, plus 3 is negative 1. Again, the x does not change. 2 times negative 1 is negative 2, plus 3 is 1, and x doesn't change. 0 times 2 is 0, plus 3 is 3. X doesn't change. 2 times 1 is 2, 2 plus 3 is 5. And then 2 times 2 is 4, 4 plus 3 is 7. So now we're going to plot those points. Okay, so negative 8, and again, normally these are the ones that you would plot, and that should be enough to graph the function, but for now, at least at the beginning, include the ones on the outside of the yellow box. So negative 8, negative 1, negative 1, 1, 0, 3, 1, 5, and 8, 7. Okay, starting with the inflection point, so 0, 3, go out, and then 0, 3, you come down. So there's the graph. Okay, so for number 11, h is positive 3 and k is positive 2. So the x's are going to increase by 3 and the y's are going to increase by 2. Okay, so we have negative 5, 0, and 2, 1, 3, 2, 4, 3, 11, 4. Okay, so these are the ones that we would normally graph, but I'm asking you to do the outside ones just to make sure you get the right graph down and not confuse it with a cube function. Alright, so negative 5, 0, 2, 1, 3, 2, 4, 3, and 11, 4. Okay, and so connect to points and connect the other 3.